What is local buckling and why does it fail? Imagine a tall, slender column standing under pressure. It looks solid, but sometimes just a small part of it suddenly bends or warps. That's what we call local buckling. It's a kind of failure that happens when a tiny section of a structure, like a beam or a plate, deforms because of compressive stress. This deformation stays confined to a small area, not the whole structure. Local buckling often occurs in parts of a structure that are thin or narrow compared to their length or width. Think of steel beams shaped like the letter W or channels. If the flanges or webs are too thin, they can buckle locally when they are squeezed or pushed. This buckling weakens that specific part, making it less able to carry weight. But interestingly, it might not cause the entire structure to collapse immediately. This failure happens because the affected area loses its ability to support the load. Once a section buckles, it can no longer hold the same amount of weight. This can cause the deformation to spread or worsen if more load is applied. That's why designing against buckling is so important. Engineers need to consider how parts of a structure behave under stress, especially when they are slender or thin. In many mechanical failure scenarios, local buckling is a key factor. It shows how even a small weakness can lead to bigger problems. If the local area buckles, it can trigger a chain reaction, causing more deformation or failure elsewhere. To prevent this, engineers use specific design strategies. They might increase the thickness of the material, add stiffeners, or choose stronger materials to resist buckling. Understanding local buckling helps in making safer, more reliable structures. It reminds us that paying attention to small details in design can prevent big failures later on. When designing against buckling, it's all about balancing material strength, shape, and size to keep every part of a structure stable under different loads. This way, we can build things that stand tall and stay safe, even when pushed to their limits.